Which of the following are sciences? Chemistry, statistics, music, herpetology, psychology, archaeology, art, economics, linguistics, underwater basket weaving? How do you know? Are you sure about that? After all, what is science? Hi, I'm Callie Moore, and I love science. Specifically, I like paleontology, and I manage the fossil collection at the University of Montana. Since I've spent a lot of time studying science, thinking about science, and doing science, I'm here to guide you through Study Hall's Science Tune-Up, where we'll talk about all things science, what we know, how we know it, and how you can go forth with curiosity and confidence to learn more. When you hear the word science, chances are you think of things like lab coats and beakers and DNA helices. And you probably pretty easily identified chemistry and herpetology as sciences, assuming you knew that herpetology is the study of reptiles and amphibians. But that's just one way to think about science. In fact, the word science itself comes from the Latin word scientia, which just means knowledge, awareness, and learning. And while our modern definition of science isn't quite that broad, it still covers a lot. These days, we tend to use science to refer to both the stuff we know about the natural and physical world and the evidence-based system we have for understanding everything around us. In other words, science is both a body of knowledge and a process of discovery. It's something we know and something we can do. And recognizing that can help you understand science and your place in it more broadly. Which matters because we've been doing science to build our knowledge of science for a really long time, like way before anyone was using the word science. Ancient Egyptians and Mesopotamians made detailed astronomical observations, paving the way for the Greco-Romans and the Islamic Golden Age that would shape modern mathematics and medicine as we know it today. Ancient China developed expansive hydraulic engineering techniques, and the Indus Valley civilization had water management systems that included drainage and sewage. Meanwhile, some Aboriginal and Torres Strait Islander peoples used control burning to manage landscapes, encouraging new plant growth, and supporting biodiversity. And Mesoamericans were making maize more nutritious with an alkaline solution that released vitamin B3. As in all knowledge systems, these observations and methods were shaped by broader beliefs about the nature of reality. Like, they were absolutely doing cool chemistry and making accurate observations about astronomy, but they generally interpreted them as parts of an interconnected whole, simultaneously engaging with astrology or unseen spiritual dimensions. A lot of our modern grasp on science was first articulated in Europe around the 16th and 17th centuries, as wealth and ideas streamed in from the age of exploration and the first wave of colonization. When combined with innovations like the printing press, knowledge became more accessible, and natural philosophers evolved into scientists like Copernicus and Isaac Newton, launching the scientific revolution. These early scientists also developed new tools, like the telescope that showed us the planets, or microscopes that revealed tiny worlds beyond the human eye's reach. That process divided philosophy from science, rejected long-held Greek views of the natural world, and placed science above Christianity as the dominant way of understanding the world, all while opening the floodgates for advancements in specialized fields like medicine, biology, physics, chemistry, and on and on. And we still have those specialized fields and lots of other ways to categorize science. Like I said, science is broad, so breaking things up into categories and fields helps us wrap our minds around it all. Like, maybe you've heard of someone talk about hard sciences, like physics and chemistry, or soft sciences, like sociology or economics, or even formal sciences, like math and computing. Or maybe you've heard of these three: the physical sciences, life sciences, and social sciences. Each of those categories can be further broken down into more specific fields and branches, and we'll dive into them more in the next 3 episodes of our Science Tune-Up. But in general, the physical sciences study the non-living world, things like physics, chemistry, geology, and astronomy. The life sciences focus on the living world through biology, ecology, and botany. And the social sciences study human society, relationships, and behavior through things like psychology, sociology, anthropology, economics, and political science. There are also nearly endless categories based on the specific thing the science studies, like zoology is the study of animals, and it includes all kinds of narrower categories like herpetology, ornithology, and ichthyology. But even then, categorizing the sciences isn't a perfect science. There's overlap and crossover and fields like biochemistry and paleozoology that smoosh things back together. That's because, like I said before, science is kinda, well, everything. You need math for physics and physics for chemistry and chemistry for biology and biology for psychology and, well, you get the gist. And hey, underwater basket weaving might not be a science, but it definitely involves some science. We can see that overlap and crossover in all kinds of scientific discovery, which is partly because the process of building our scientific knowledge isn't straightforward. It can take years of work by hundreds of people involved in all kinds of different processes and fields of study. Here's just one example of what it can look like to do science and build our knowledge of science. It involves life sciences, specifically ecology and entomology, but it actually starts with art, which you might have said is not a science. Born in 1647, Maria Sibylla Merian was a naturalist and scientific illustrator. As a child, she began closely observing and painting plants and insects, specifically caterpillars. She spent years collecting and caring for plants, larvae, and caterpillars, so she could watch them and accurately record their behavior. She noticed which plants they ate and which other species they interacted with, and she painted different stages of the life cycle: eggs, cocoons, and butterflies. And that was key because at the time, insect life cycles were not widely understood, and the general belief was that caterpillars and butterflies were different and unrelated. Marian's observations and paintings provided visual evidence that insects hatch from eggs laid by mature insects, and she documented the metamorphosis of caterpillars into butterflies. Eventually, Marian published books of her paintings, and her work contributed not only to our understanding of caterpillars, but also to the development of the field of entomology and standards for accurate scientific observation and illustration. In Miriam's work, we can also see glimpses of what would become our current dominant approach to science. This approach evolved over centuries with input from famed thinkers like Aristotle, Ibn al-Haytham, and Sir Francis Bacon. And it generally follows a blueprint called the scientific method. It's a way of acquiring knowledge through a rigorous testing process that can be repeated and that holds up under scrutiny. Chances are you've encountered this method before. The idea is that you start by making observations and asking a question. Then you develop a hypothesis, a potential answer to your question. You experiment and test your hypothesis. Then you analyze your results and draw conclusions. In the end, you communicate your findings with others. We don't know for sure how closely Marian followed this process. We don't know if she formally made a hypothesis about caterpillars or designed specific experiments to test that hypothesis. She may have tested different variables, like putting caterpillars on different types of plants to see if that changed their behavior, or observing what happened if she moved the eggs before they hatched, or the chrysalis before the butterfly emerged. In any case, she was definitely making observations, gathering data, drawing conclusions, and communicating her findings. And the thing is, the scientific method isn't always a straightforward process that follows the steps exactly in order. As we'll discuss in some of the other episodes of our Science Tune-Up, some scientific fields require adaptations to the scientific method, or following the steps in different ways. And sometimes your hypothesis is wrong, or the experiment doesn't work, or you have to ask a different question or go back and try something new. It helps to be prepared for that reality. Sometimes science can be really tedious, endless, full of unexpected results or curveballs that leave us banging our heads against a desk. For example, Marion observed wasps coming out of caterpillar cocoons. Freaky and probably not what she expected. She called it false changes, but it might have been the first recorded observation of insect parasitism. The point is, those unexpected results and curveballs are an important part of the process. In fact, it's why we have the scientific method, to give us a blueprint for doing science well and knowing when science is done well. See, the scientific method values empirical evidence, which means asking testable questions and collecting data so that we can feel pretty confident in answering those questions. And while it's pretty hard to be objective, the idea is to come as close as you can by making sure you've achieved a result that can stand up to repeated testing over and over, no matter who's doing it. And there will be repeated testing. Scientists are constantly asking questions, finding information, asking new questions, testing new ideas, and building on what's come before to develop our knowledge of the world. And scientific conclusions are always being tested and revisited. Sometimes we confirm the same results over and over, and sometimes we learn something new that uproots our previously held ideas. Recognizing that helps us understand what's going on when a scientific conclusion is overturned by new evidence. It makes it less confusing when there are new recommendations about what medicine to take, or what food to eat, or what kinds of tools to use, or how to do our job. It also helps us understand what's going on when scientific evidence repeatedly confirms things we already know, like the importance of vaccines, or that our planet is rapidly warming due to human reliance on fossil fuels. And it shows us that there's still plenty of work to do in the sciences. Scientists are still debating everything from whether the multiverse is real to what it actually means to be human. And they're considering the ways the scientific method can work with and alongside other perspectives and ways of knowing. For example, Indigenous perspectives reflect a deep understanding of the natural world that's based on observation and storytelling. They value respect and reciprocity in their relationships with the natural world and place less emphasis on objectivity. Their methods for studying and explaining natural phenomena can help us with all kinds of things, like better understanding our bodies and better caring for the planet. All of that means there's plenty of time and plenty of space for more people, like me and you, to ask questions, work on figuring out the answers, and add to the story of science. If that's interesting and exciting to you, stick around. In the next 3 episodes of our Science Tune-Up, we're going to take a closer look at the scientific method and how it's used in different fields. We're going to show you what it looks like to study science, help you brush up on what you already know, and help you figure out where you might want to learn more. Because, as we've seen, science is broad, and getting started or getting back into it can be intimidating. But one of the cool things about science is that it's all about figuring out what you don't know, asking questions, and coming up with ways to get answers. So what is science? Let's find out. If you're currently in or thinking about going to college, go to gostudyhall.com for more student resources and check out our $25 college courses. Thanks for watching. See you next time.